Do you think that there is something more that we just don't know what that is, or is this emergence?
The heart of these systems is a large language model, and exactly the way you described. These models are trained on one task, the task of achieving coherence in a long passage by accurately predicting what's the next best word.
Welcome to Lahore, Professor Porter. It's wonderful to have you here.
Thank you, Amir. It's a pleasure.
What I thought was that we would talk about artificial intelligence and where it's going, your long association with the field, and also maybe personalize some of these questions to the context that we're currently in, which is the country of Pakistan, and particularly the use of AI for development. But before I do all of that, I wanted to just quickly introduce you to the audience. Professor Porter is two-time chair of the University of Texas at Austin, which has been number 6 computer science school globally, one of the strongest AI programs in the world. And Professor Porter now serves as the Chief Science Officer for SparkCognition, of which I am founder and CEO, a company based in Austin, Texas. So with that brief introduction, Professor Porter, there seems to be a great AI resurgence, particularly in the last 6 months, with ChatGPT, GPT-3, and now GPT-4. What has suddenly happened that has caused these AI models to do so many tasks so well?
Yes, that is the million-dollar question, Amir. First, to put it in a little bit of historical context, the basic technology that these modern generative models are using is not new. It goes back to at least the 1980s, when neural nets and subsequently deep neural nets, which are a little more complex, were invented and have been used for a variety of problems, challenges. The fact that deep neural nets have now broken out in this way and caught the popular attention is not so much to do with the technology as it is to do with the way that popular culture works.
Yeah.
But having said all of that, let me admit to my own surprise, my own delightful surprise, to see that in these last few years, the generative models have again surpassed my expectations. And I can say with sincerity that over the past 2 or 3 decades, I've been continually amazed at the progress that the field of machine learning has made. And generative AI and ChatGPT and DALL-E and the like that we're all reading about these days are just the latest.
Yeah. So one of the things that's been a big criticism of models like these is that essentially all they're doing is they're predicting the next word or the next token in a sequence. So when you, for example, confront a model like this with Mary has a little, the likelihood is that the model will complete that sentence with lamb. Mary has a little lamb, because that's such a common sentence in the literature and these models have been trained on that. But if that's all it's doing, many of the reasoning capabilities, many of the mathematical capabilities, many of the engagement, conversational capabilities that it brings about seem to rely on something more. So there already is a sense of more beyond just this basic task. Do you think that there is something more that we just don't know what that is, or is this emergence?
I think a lot of it is emergence, and here's why I believe that. The heart of these generative models is a large language model. So at the heart of GPT-3, GPT-4, and the chat versions of these systems, the heart of these systems is a large language model. And exactly the way you described. These models are trained on one task, the task of achieving coherence in a long passage by accurately predicting what's the next best word to lay down in a sequence while the system is generating a text.
Yeah.
So it's very good at that, and it's addressed a core problem that chat systems have had over the years, which is that as the discourse gets longer, the discourse becomes incoherent, just babble, and it seems as if the system has lost the thread. So that problem has been addressed by, I think, by emergence. It's been addressed by increasing the size of these models now to where they're in the hundreds of millions of parameters. And I'll describe in my talk later what I mean by parameters, but for now, just think of it as the size, the scale of the model. And changing nothing but the number of parameters
Right.
over the last several years has given us this steady and amazing progress in addressing the coherence problem.
Yeah.
So in that sense, I think we have emergence. But also to your point, I think there is a secret sauce that is being added to the chat versions of these systems, like ChatGPT. The chat versions are adding reinforcement learning to enable a discursive presentation, so that a user can prompt the system to generate a text, and then follow up that with a request to tweak it in this way, extend it in this way. So it becomes a discourse.
Yeah.
And that's being enabled by reinforcement learning on top of the large language model.
Yeah.
So I think there is a little bit more, but I would credit that little bit more as maybe 10% of the total success that we're seeing today, where 90% is simply the emergent property that you get by increasing the scale of the model.
Fantastic. Now, we do want this talk and these answers that you're so graciously providing to be accessible to as large a number of people as possible. And there's a few terms of art that we used. For example, we spoke about emergence,
Yes.
we spoke about deep learning, and then we spoke about reinforcement learning.
Yes.
If you would be so kind, would you describe, perhaps even in a nutshell, what each of these three phenomena are?
Certainly. Let me start with maybe the hardest one of all, emergence. The field of AI started in the mid-1950s, and the goal at the time was to understand human cognition so well that you could build a computer program that is intelligent in the same way that humans are intelligent. And again, the idea was, let's base this understanding on the human model. So that was the initial goal for artificial intelligence. And through the decades that followed, there was significant success in AI, causing a series of disruptive technologies, but none of them addressed that core goal of building a so-called general AI, one that has the breadth and skill and ability of a human. Instead, what's been developed is what's called narrow AI systems that achieve success, often remarkable success, but at a very narrow task.
Yeah.
Emergence is crossing that barrier. Emergence is starting with a narrow system, or maybe a family of narrow systems, and just simply adding more horsepower, scaling them in some way to have emerge from that chemistry a general AI system, one that mimics human cognition across the board.
Where the interactions of these narrow AIs cause a greater intelligence to come about without explicit design.
Right.
Yeah.
Without explicit programming.
Yes.
So that's emergence. You asked me also about reinforcement learning.
Yes.
Reinforcement learning is just one method in a family of methods that we call machine learning. And where reinforcement learning addresses a particular niche or a particular need, and that is the ability to sequence a set of actions, to have a computer program that's able to sequence a set of actions so that through the course of this series of actions, some goal is accomplished.
Correct.
So it's not a single shot system. Instead, it's one that's intended to achieve a goal over a series of actions. In the case of these chat systems that prompted this question, the series of actions is the discursive nature of chatting with one of these AI systems. So reinforcement learning is being brought to bear to improve the performance over the series of chats or the series of turns in a discursive dialogue.
Fantastic. One of the areas that you and your research team have been very focused on over the last few years now is generative AI. And in fact, ChatGPT is one example of a generative application.
Yes.
And from the word generative AI, one gets the sense of the AI actually producing data, unseen data, new data
Yes.
that wasn't part of its training set. So to be able
Right.
to come up with a new sentence or a new picture, that's the generative part in AI.
Yes.
How have you applied generative AI and the recent announcement that you made about the availability of your generative AI platform for industrials? Tell us a
Yes.
little bit about that.
Yeah, I certainly will. And let me put a finer point on what we mean by generative AI. What we've done over the history of AI is to build recall systems or retrieval systems, ones that are capable of taking some query or prompt from a user and returning something from the archive that satisfies that interest, that prompt. So that's retrieving information. Generative AI, in contrast, creates something new out of whole cloth. So we're seeing that with ChatGPT and DALL-E as being systems that are producing text or pictures that are new to this earth.
Right.
Now, those are fun systems, no doubt, and I've had an enjoyable hour interacting with them, and they're cute, and I think that they will do lots of things for humanity. At SparkCognition, though, we're also interested in what this technology can do for industry, for hardcore industrial problems. One of the problems that my research team has been working on at SparkCognition is using generative AI for the problem of seismic imaging.
Yeah.
This is a problem that the oil industry has faced for decades.
Right.
Of course, they've done oil exploration for decades using seismology, seismic imaging. The problem with that technology is that it's very slow. It will take a super major 9 months to survey an area, say of the Gulf of Mexico or the North Sea. They came to us to ask if we could use generative AI to reduce that from 9 months of time to compute a seismic survey to something on the order of 9 days. So a 30-fold speed up.
Wow.
And we've accomplished that. This is a game changer for the industry. It enables not only searching for deposits of oil, but can also be used for finding geological structures deep under the sea that can be used to capture, sequester carbon.
Wow.
So this would be a way of finding those sites where we could inject carbon and safely sequester it for centuries.
That is amazing. And clearly, while chatbots are cute, as you said, this is a world-changing application in terms of the environmental impact and, of course, the ability to deliver energy to where it's needed in large quantities. Fascinating. Now, we are in Pakistan, and over the last few days, you've had an opportunity to sort of go around and meet with some people, and there's a few more meetings coming up ahead. For Pakistan or for developing nations in general, your focus has been in applying artificial intelligence to infrastructure.
Yes.
And my long-held view has been that infrastructure is what makes the world go round. It is what is the provider of plenty. It's a very important capability in any economy to keep power going, to keep clean water going, to provide water for irrigation, all of these things that one needs.
Yes.
How do you feel artificial intelligence can be applied in this context to improve odds, particularly low-lift applications of AI?
Right. What we're seeing in industrial applications in the last 10 years or so is an enriching of this technology. Think industrial pumps, think gas turbines, and enriching of this equipment with sensors.
Mhm.
So abundant information is being generated by these devices. It's not currently being used.
Yeah.
With AI, there's the potential of harvesting this data and turning it into predictions
Yeah.
that can help to improve efficiencies, able to predict when the equipment may fail,
Right.
how it can be optimized for better performance.
Yeah.
We worked recently with a cement manufacturing facility in Pakistan. And with our AI modeling, found ways of reducing the use of electricity, which is huge in these cement plants, by optimizing performance of their equipment.
Yeah. In fact, there was a public announcement about Maple Leaf Cement, which is where your system was deployed, which is
Yes.
where it's now been adopted. So there's lots of potential, I think, in other industry in Pakistan as well. But another point that you made, which is that data has value,
Yes.
right? Data allows you to learn and train better algorithms. And most of the infrastructure in not just Pakistan, but much of the developing world isn't being used as a source of data. Even if that infrastructure has sensors,
Yeah.
the operators of the infrastructure aren't collecting the data as a resource to build future value, to learn more about their equipment, and even to build derivative products that themselves have value that they could sell down the road. So I think that's another low-hanging opportunity for a lot of infrastructure operators to be able to simply capture all that data and then work with an AI company to productize that captured data for the benefit of other similar operators of that type of equipment.
I agree completely. And let me just take a moment to speak to the students in the audience.
Please.
There's this new field of data science. This is a remarkable field that's going to change the future. It's the core of artificial intelligence. So building AI models starts with having a firm footing in data science. The cool thing about data science and artificial intelligence applications, say to industry, is the breadth that it provides, the power. You can, if you're a student and you're looking for a place to make an impactful contribution, think about this. A data scientist is able to apply her craft to a variety of industries without knowing how cement is actually manufactured, without knowing how power is actually generated.
Yes.
What you do is study the data, and in the data lies insight into how those kinds of devices and processes can be optimized.
Yes.
And this is without knowing anything about those processes.
Yeah, the basic principles.
The
You
basic
don't know.
principles.
You're not a physicist.
That's right. So it's a way of having huge impact out beyond an outsized influence.
Yeah, fantastic. And of course, that same approach of data-driven decision-making and data-driven insight mining can be applied to pretty much any domain, even beyond industrials.
Exactly.
So that's fantastic. Professor Porter, as the audience develops interest in the topics that you've spoken about, what pointers would you give them? What reading would you suggest? And if somebody wishes to contact you, how might they do that?
Good question, Amir. First, to the last question, please do contact me. Again, my name is Bruce Porter. I'm the Chief Science Officer at SparkCognition. And with that alone, I'm sure you'll find me on the web.
Of course.
And I'm sorry, previous question.
Any reading recommendations?
Oh, yes, thank you. The thing, I'm not going to recommend particular books or particular articles because there's so many.
Yes.
Instead, let me just give this advice. Get into the subject. Get beyond the popular press. Get beyond the superficial, gee whiz articles. And there's lots of places to do that. YouTube is full of informative documentaries or videos on how the technology works. Textbooks that are used at universities in the introductory AI courses, another great source of information.
Do you recommend the Russell Norvig book?
The Russell Norvig book is the one that we use at the University of Texas, and it's a very good book. But again, the key piece of advice is go deep.
Yeah, fantastic. Well, Professor Porter, thank you so much for your time. This was a lovely discussion, and hopefully we'll be able to keep this up.
I hope so.
Thank you.
Thank you.